All right, welcome back. We are moving into limits today, which is going to be pretty amazing. I have to say, they're pretty awesome. But before we do this, let's pause the video and try these three problems for warm up. Give you about 5 minutes. Ready? Pause. All right, for the first one, hopefully you got to see a little bit beyond just these numbers and how they work. Let's check and see if it's first and second differences first. So if I am looking at from here to here, oops. Oh, great, my computer's being weird. Okay, so 24 to or 26 to 34, that's 8. Oh, this is not going to be good. Okay, so this is 8, and this is 10, this is 12, and this is 14. Now, hopefully you recognize, that's a second derivative, or sorry, second difference of 2. So that means we can use our calculator to find the second difference. So on your calculator, you go to Stat, you go to Edit. We only have 5 given, so we can write it as 26, 34, 44, 56, and 70. Delete and delete. Delete, delete. All right, so if we go to Stat, go to Calculate, and go down to Quadratic Regression, like we did yesterday, press Calculate, and we end up with, what is that? N squared plus 5, N plus 20. There you go, squared. All right. For the second part, bigger degree on top, that means that it diverges. Bigger degree on, same degree, that's 4/3, converges. And then this one, bigger degree on the bottom, that converges to 0. Simplifying this expression, we got a bigger value on top, so that's n plus 2 times n plus 1 factorial over n plus 1 factorial. Cancel, cancel. N plus 2 is our answer. As promised, we're talking about some limits. Yeah, the speed limit is infinity. That's so crazy. I love that graphic. Well, let's go ahead and evaluate some limits graphically. We're going to evaluate one-sided limits. We're going to determine whether a limit exists using one-sided limits. So the big deal about today is making sure that we remember we've already talked about limit notation. So please stick with limit notation. Don't forget that that's how we write in behavior. But now we're going to we also did it for asymptote behavior. But now we're going to dive into it a little further. If you printed out your notes, these are some words that you need to make sure you get on there. It says the limit of a function is the value of the function as you approach it at a given point. Everybody say approach. Approach. Good work. All right. So that means if I'm moving towards it, like if I'm on a car, I'm in a car, I'm going towards something. What am I approaching as I get close to that given point? So right here, the limit is x approaches -3. If I go over here, at -3, if I actually said, hey, what is f of -3? I don't know what that is. That's a big hole. But what am I approaching? Not what is it there, but what am I approaching on either side? What y value am I approaching? I'm actually approaching 1. 1 is the value I'm approaching. Doesn't mean that at that point you have it. Just what are you approaching? So let's go ahead and take a look at a one-sided limit versus a two-sided limit versus an actual limit. So a limit to the left, if I say, hey, what's happening on the left side of this? I'm going to show you that with this little symbol right here. There's a little negative on the upper right corner, and then we've used this before to talk about left and right sided limits for asymptotes. So that right there is what you would see if you were on the right side. So it's as you're approaching from the right or as you're approaching from the left. That's kind of review. But if you forgot it, now hopefully you remember. Now, if the left-sided limit equals the right-sided limit, then the limit is that same value. Whatever L and R is, it's that. Okay, and the limit is always a number or it does not exist. Okay, it's always a number or it's a limit does not exist. All right, so if f of x becomes infinitely close to a value as in as x approaches c from either side, the limit of f of x as x approaches c is in. That sounds super complicated, but here's what's happening. If I'm approaching from the left and I get L, if I'm approaching from the right, I get R, and I say, oh, wait, those are the same numbers. So I can say that the limit just at C with nothing up here is the same, but that's N is the same number as L and R. I think it gets a little complicated when we talk about this. Again, when it's always a number, it does not exist. That was just another way to say the same thing. Now, when does it not exist? There are a few things that happen. When does a limit not exist? Well, if the right limit doesn't equal the left limit. If you're looking at your graph and you say, oh, that's approaching 2 on this side, oh, it's approaching 5 on the other side. Those are not the same numbers, so the limit does not exist at C. If there's no limit on one side of C, that's another case. If you think about something like the square root curve, if I'm approaching 0 on the right side, I approach 0. But if I approach 0 on the left side, that's not happening. There's nothing happening on the other side. So that would not exist. And then also if there's a vertical asymptote, then the limit for that value would not exist. But the last one is this really cool one with oscillation between 2 points. So that's really confusing and students really have a hard time wrapping their head around that. But if I said, what is the limit as n approaches, oh, let's see, like 0 for sine of 1 over n. So it's super weird, but like as you get super close to 0, you're actually getting some really big value in the inside, and it oscillates between values just like the sine curve does, but it does it so fast that you're never going to be able to tell me what's happening as you approach 0. Is it -1? Is it a +1? Is it anything in the middle? You don't know. So it's so crazy. So that's just a special case, but we have to write it because it is part of this does not exist slide. All right. We're going to work through all 4 of these, but today we're focusing mainly on graphically. How do you find a limit graphically? So we have a picture. Find the limit as x approaches 1 from the left. Pause the video, and I want you to try the left, the right, and the value. Pause it now. All right, from the left, we are going here, and it looks like we're approaching 2. All right, and from the right, we're coming here, and it looks like we are approaching 1. So, are those the same numbers? No, 2 is not the same as 1. So we would say D, N, E, the limit does not exist. Pretty straightforward. All right. Pause the video now and try these 2 separately. See if you can figure out what the limit would be. Pause it now. All right, for the approaching the left of 2 is a does not exist possibility. There's nothing happening on the left side of 2. Like there's nothing over here. So I don't see anything. I can't write a value that it's approaching. The right side is approaching 5, but as far as what 2 is approaching, that's a does not exist as well. Okay, because one of the sides doesn't even exist, so you can't say that.